Imagine you are building a robot to clean your room. The robot must figure out how to pick up many different objects. Then, the robot needs to know how to neatly put those objects where they belong. The robot needs to overcome a number of challenges in order to complete its tasks, including perceiving things from changing perspectives, overall changes to the body as metal rusts and gears dry out, and processing time requirements. How would you design this robot? To solve the robot's problems, we look at how humans have evolved to overcome these challenges. As we move, our physical view of things often changes. For example, if we look at a table from above, we view a square. But if we move to look at the same table from the side, we view a rhombus. Even though we view a different shape and different information is sent to our brains from this angle, we correctly perceive that it is the same table that is top a square. We also view things differently as our bodies change. As humans age, we both grow and shrink, leading us to view things from different perspectives. Yet, even after time, we are still able to perceive things the same. Humans are also able to quickly make sense of things we view. Since every action needs time to happen, complicated thinking can be slow, and thinking that takes a lot of time is not always good for doing things quickly. Imagine knocking an object off a table. You only have a split second to gather information about the object's shape and location. Then, move your arm, open your hand to the right distance, and catch the object with the right amount of force. No time to think. To solve these problems, humans use relationships between our body and the things we view that are stable, even when other things change. For example, how people perceive the size of a doorway is based on a stable relationship between how their eye height relative to the ground changes with their body size. Since this relationship is stable, people do not need to think about it as much. Even if the doorway is in a different location or the door is in a different color, we still perceive it as big enough to walk through. These stable relationships between our body and the world tell us what we can do with things and are called affordances. In the example of the table from earlier, one way we recognize the table as square is because of the stable ratios between its corners relative to our eyes. As we grow or shrink, this relationship changes with us, so that is always something we can use to make sense of what we view. The stable relationship of these ratios to our eyes immediately tells us the affordance, or what we can do with the table. Is it flat? We should be able to put a cup on it. Even though the affordance is not consciously obvious, it works well with our body and allows us to engage in the world around us. But knowing if we can walk through a doorway or set things on a table seems simple. Can we use affordances for more complex tasks that seem to only use the brain, such as solving physics problems? Say you are catching a baseball. One way to do this task is to figure out the path of the ball in your head. This involves several complex geometry and physics calculations. Research shows that people are bad at doing this calculation quickly enough to catch the ball. Besides, wind, air resistance, ball spin, and other factors can make all of it extra difficult to decide where the ball will end up. Yet, expert baseball players are great at catching. Scientists have shown that one way people catch is by using an affordance. In this case, the affordance is the direction of the ball relative to the baseball player's own motion. By running along with a fly ball, a player can use this stable relationship that tells them where the ball should land, the affordance, instead of having to solve these equations. Now that we know what affordances are and how they can help us see the world, we are more prepared to build our room cleaning robot.
To continue learning more about the world around you, check out our previous SciTunes videos. You can also stay tuned about our upcoming projects by following us on Facebook, Instagram, and Twitter.